to live in very easily. It's a desert world, of course, very little water at the surface of that planet and a very thin atmosphere. And I always think, when we're talking about what we may do as a species and the way in which we may colonize other planets, that the paradox, of course, is that we need to design biomes for Mars that conserve. If we go and live there, we're going to have to conserve and recycle absolutely everything that we need to survive. Whereas we live on this wonderful planet Earth, and here we're polluting, we're not recycling, and we're not paying due care and attention to the environment around us. So that was kind of by way of a little preamble, just to remind us of how special the planet is that we live on. And now a bit of navigation. What I want to do in this talk with you is to introduce the Anthropocene, talk a little bit about life in the Anthropocene, maybe explore what's driving the major changes around us, actually ask the question, when did we overwhelm the Earth system, and how we can actually see that in the landscape. Can we see the Anthropocene everywhere we look? And then at the end, try and take stock of where we sit as a species in terms of what we need to do in the near future. So first of all, what is the Anthropocene? And I want to begin with some global figures. I'm sure you know that about 2 months ago, we passed a planetary threshold. There are now 8 billion of us on this planet. That's a number that I find really difficult to conceive. I can't really think what 8 billion people would look like. Even if you think about some of the huge structures that we live in, and we're increasingly living in these huge structures, I think it's quite difficult to think about the 18 million people that live in New York City, for example, or the 13 million people that live in a city like London. Let's bring it down to a smaller scale. Let's think of a city like Leicester, a rapidly growing city with about 370,000 people in it. We can probably manage now. We can probably think about 370,000 people. That's perhaps 4 large football stadiums full of people. And then we could bring it down to the smaller town scale. We could think of Market Harborough, for example, a town with about 25,000 people in it. We can get a sense, I think, very clearly of what 25,000 people looks like. Now, I've done that deliberately because I thought it would be really interesting to compare you and I in terms of our numerical abundance with our 2 closest cousins. How many do they number?
Hi,
If we
Mark.
think about,
Sorry.
oh,
Your slides aren't moving.
oh,
You
oh
just want to
dear.
take them down and reshare them again, please.
Yes, I
Sorry.
can do that. So they're moving on my screen, but obviously not on yours.
I can still see Mars. I
Oh
don't know about
dear.
everybody else.
Okay. I've moved on quite a long way from Mars.
Sorry.
So where shall I go back to? Do you want me to go back to Mars and begin again, or do you want me to just see if it
No,
will work
no.
from where we are?
Share from
From where we
where?
are.
Yeah.
Okay. Oh, that's a shame. Missed some nice images, but can you see
Yeah, can
chimpanzees?
see that.
Yeah, great.
Yeah,
Okay.
see that now.
So
Sorry, Mark.
that's okay. If it happens again, Kaylee, please ask again, and I'll do the same. So I'm sorry
I'm
about
very
that,
sorry,
folks.
I can't see anything except for Mars at the moment, so it's still not moved on my
Oh,
screen. Apologies, Mark.
let me see if I toggle backwards and forwards. Does anything happen?
No, it's still on Mars.
Oh, I don't know. I mean, I don't know what that problem will be, but I'll go out of this again. Try again. Still on Mars now?
I can see okay. If people could let us know in the chat.
I'm just toggling backwards and forwards at the moment.
It's moving now on my screen.
Excellent.
And people are saying that their slides moving in the chat as well.
Okay, I'm really sorry about that, folks. Must be some technical problem. It's moving on my screen, but obviously not on everybody's. Just to catch up, we were talking about our numerical abundance as a species. And I was going to compare it with our two closest relatives, the chimpanzee, about 250,000 chimpanzees in the wild, and the beautiful bonobos, about 20,000 of them in the wild. And just to make the point that our 2 closest relatives account for 1 medium-sized human city and 1 small town. You know, chimpanzees are Leicester and and the bonobos are market harbourer. And that's because you and I are more than 99.9% of the numerical abundance of all primates on this planet, which is a staggering figure for any one member of a major animal group like this. And we are really the major geological agents at the surface of our planet. We move something of the order of 316 gigatons of sediment a year, 150 cubic kilometers, much more than all the world's rivers. We use vast amounts of water, about 4,000 cubic kilometers a year, which is something that I can't conceive of. So, but it is the equivalent of emptying Rutland water every 16 minutes, which is quite remarkable for a single species to be able to do that. We use vast energy. That energy level has grown, of course, as human population has increased, though, of course, the spread of usage of that energy is very uneven between very wealthy countries and less wealthy countries. We've changed the atmosphere. We put about 38 billion tons of carbon dioxide into the atmosphere each year, which is obviously very germane to this broader kind of seminar series. And we dominate land and sea. And for me as a paleontologist, somebody who looks at the evolution of life on planet Earth over long timescales, no other species ever did this in the 4 billion year history of our planet. Hopefully my slides are moving okay now. If they're not, please tell me. So what you should see now is evidence of the scale of planetary change in front of you, which is a figure which is trying to plot over the past 12,000 years, going from the Pleistocene epoch of geological time through the Holocene, some of the substantial changes that you and I have caused to the Earth system. A doubling of reactive nitrogen at the surface of our planet as a result of our use of nitrogen in fertilizers. A significant rise in atmospheric CO2 as a result of the burning of fossil fuels, and a concomitant rise in methane as well. And that, of course, has had a very, very significant impact on climate, with a more than 1 degree Celsius mean surface temperature rise on our planet since the 1970s. And now, these projections are moving much faster than they have in the deep time geological record. So the Anthropocene, just to explain what it is, represents a new geological epoch of time, one that means we no longer live in the envelope of the Holocene, which is the period of time in which human civilization has developed. We now live in a time when humans have simply overwhelmed the great forces of nature, which I hope I've been able to demonstrate to you in some of those introductory slides. I now want to think about how that might actually impact on the biosphere, so life on this planet and its interactions with the other great spheres of air and water and soil. How is the biosphere changing in the Anthropocene? We know that there's about 1 million species at risk of extinction. It may indeed be many more than that because we haven't quantified most of the biodiversity on this planet yet. And if you Google extinct animals, of course, you get the big things that everybody notices. Everybody knows about the demise of the dodo, and probably the beautiful Caribbean monk seal, which has not been seen since the 1950s, and the beautiful Yangtze dolphin, which has not been seen since the early part of the 21st century. How many of you, I wonder, know about George the Hawaiian tree snail? Because George went extinct at the beginning of 2019, and his loss is important in terms of biodiversity, but George as a species was also very important to the broader ecosystem in which he lived, and his brethren snails lived also. So this is a real loss, not just to biodiversity, but to the structural integrity of the biosphere. And George is part of a much bigger extinction. We now estimate that maybe as much as 13% of snails, mollusk species have gone extinct over the past 5 centuries. And that's a very, very significant change to the biosphere. Now, extinction is a big part of the Anthropocene, and our impact as a species, though, appears to be even more special than that. Because we've halved the mass of the biosphere over the past 10,000 years, most of that by cutting down forests on land. And that's well quantified. Half the mass of the biosphere has been removed by human activities. You can see that in the Leicestershire landscape, just in the lack of trees that we have in our landscape. And we've concentrated mass in those things that we like to eat. It's another quite terrifying figure, I think, that humans and their domesticated animals are 96% of the terrestrial mammal biomass. So all of the wild terrestrial mammal biomass is 4% of the mass. And we change the landscape, of course. We can see that in the landscape of Leicestershire around us, but we've done it on a global scale also. Here, plotting some data from a colleague of mine at the University of Maryland, Earl Ellis, just to show you how humans over the past 3 centuries have converted most of the habitable landscape to environments in which they are used. That means they're heavily inundated by humans, or in many cases, very highly modified by humans, the semi-natural states which are shown here. And more recent estimates have suggested that as much as 95% of the ice-free surface of our planet is in some way modified by humans. So that we could argue actually that the world is no longer dominated by natural ecosystems with humans disturbing them, but it instead is dominated by human systems with remnants of natural ecosystems embedded within them. You see that everywhere you travel within the Leicestershire landscape. We profoundly changed the organisms within those ecosystems. So this is what we did to chickens over the past 7 decades because we like eating them. And another striking figure for you, chickens are 70% of all bird biomass on planet Earth. All wild birds, all other birds are only 30% of the biomass. So this again is a radical change to the biosphere, which is being caused by humans. We've even smeared biogeographical boundaries. We see that in the Leicestershire landscape too with introduced species. But even across some of the very famous biogeographical boundaries like the Wallace Line in Southeast Asia, which was formative to our understanding of evolution on this planet, because many of the introduced species, like the golden apple snails from South America, couldn't care less about our biogeographical boundaries. They just march straight across them. And often when they do that, they cause considerable damage in the landscape if they're acting as invasive species. And of course, invasive species are nearly everywhere. We have many in the Leicestershire landscape. One of my PhD students, Amy Rysdale, is working on these at the moment, and I hope is going to make some good connections with you out there, potentially. Now, many of these changes, of course, have unfolded over millennia, but many have also accelerated very rapidly in the 20th century, which comes back to my point about this Anthropocene epoch of geological time that we now live within. We could see that in chicken skeletons, for example. On the right-hand side there, you can see the kind of chickens that were running around in the countryside 7 or 8 decades ago versus the broiler chickens that we now very rapidly produce in huge numbers. 63 billion of them are eaten every year on our planet, and they are structurally very, very different in terms of scale from the kind of natural kind of state of the chicken. Okay, I hope that I've been able to quantify what the Anthropocene is to you, and also to show you something about how the biosphere is changing. And I'm sure, although I've not been talking about the Leicestershire landscape so much, that you can nevertheless see these patterns all around us. I wanted to stop for a moment and just ask you what is driving this change to the Earth system. Because you might think it's you and me as individuals, as humans, but my colleague and friend Peter Haff at Duke University in North America would suggest that it's the technosphere. And again, this might be a term that you've not heard about before, but I think it's worth discussing in the context of this talk. What is the technosphere? So Peter would define it, as you can see on my screen there, as an autonomous global system, so autonomous from us, that comprises all of the world's humans and their technological systems, their transport, communication, power, financial networks, all of the social structures that go with that, with bureaucracies, with education, with scientific establishments, religious institutions. Effectively, everything that binds humanity together with all of its technological and information connections would be the technosphere. Now, another way of thinking about the technosphere is as we might think about the other spheres of the Earth system, the lithosphere, the solid Earth, the atmosphere, the hydrosphere, and the biosphere. These components of the Earth system that have been co-evolving for billions of years to make a habitable place at the surface of our planet for us and all of the other species that live here. The technosphere is just like those other spheres. It is everywhere you look on this planet. Even in the deep oceans, you can find evidence of the technosphere in the plastics that we've now delivered to those deep ocean sediments. The problem with the technosphere is that it hasn't co-evolved with the other components of the Earth system. And at the moment, its impact on those other components is severe. It's almost acting in a kind of parasitic manner to degrade the other components that we need to actually preserve a habitable space at the surface of our planet. Nevertheless, the double-edged sword, the problem that we have is at the moment, we need the technosphere to survive, certainly to support the numbers of us that are on this planet at present. And it's huge. We tried to weigh it a few years ago by looking at all of the different components of the technosphere, and we estimated it to be about 30 trillion tons, which is actually greater than the weight of the biosphere. Now, cities are big engines of the technosphere because it's in cities and in urban spaces where most of consumption, human consumption, is taking place. They have voracious appetites, consuming about 70% of our energy and producing about 70% of our waste. And if you then look at the kind of patterns of consumption that have characterized the later part of the 20th century, which are symptomatic of this Anthropocene epoch of geological time, caused by the actions of the technosphere, you'll get a real sense of how the urban domain is also driving the changes at the surface of our planet that are intimately and intricately connected to what happens in the rural landscape as well. So when we're thinking about these big changes, we obviously need to make these very strong connections between what happens in the urban realm and what happens in the rural realm as well. Even if you think of large cities, over 750,000 inhabitants alone. You think about the way in which they consume. You can see the figures here, transporting something of the order of 184 cubic kilometers of water over the surface of our planet every year, from about 2/5 of the global land surface. So this again has a major impact on the way in which we interact with the landscape. For a moment then, I just wanted to think about this in the context of Leicester and to think about the way in which we consume in the 21st century, as opposed to the way in which the natural biosphere would have consumed in the past. And for this talk, I did some fairly simple back of the envelope calculations, assuming that the natural biome in this area was using the energy of light that was coming in, and that energy of light, which you can calculate fairly simply, is about 1 gigawatt hours per year per kilometre squared. Now that's the energy that's incoming, but plants, of course, can only actually sequester about 5% of that energy into their biomass. So the energy available to the biosphere in Leicester, before Leicester was here, was quite limited when you think about the way in which the city now consumes. Currently, if you look at the primary energy consumption in Leicester, it's of the order of about 75 gigawatt hours per year per kilometre squared. And of course, that's all being consumed. We don't have this problem of plants not being able to use that energy. We as a species can use that energy very voraciously. It's an order of magnitude greater than what the natural biome consumes. And I was trying to think of an analogy that would convey this to you simply. And Leicester University is famous for its research on black holes. And so I was just thinking that you could think about the way that a city like Leicester has developed over the past 2 or 3 centuries in terms of its energy consumption. And that really, you know, from the early 19th century through to the 20th century, Leicester and most other cities in the developed world have become almost like black holes in terms of the way in which they consume energy at a rate which is far beyond what was available to the natural biome. So that was me talking about the technosphere and trying to bring it back to a very local level and thinking about this in the context of a city like Leicester. I just want to park the technosphere for a moment. We can certainly think of it by analogy as an accelerating vehicle, and hopefully the wheels won't fall off. And I'm going to come back to the technosphere a little bit later, but I just now want to move to the fourth part of this talk and ask you the question, or ask the question more broadly: when did humans actually overwhelm nature? When did humans, together with their technosphere, become such a global force that our impact could result in a broader degradation of the very systems that actually sustain us as a species and all other species on this planet. So let's have a look at this question over the next few minutes or so. To determine this, we need to investigate 3 different processes which are integral to human evolution and cultural development, but also ultimately to development of the technosphere. We need to look at hunting and gathering, we need to look at landscape domestication, and we need to look at globalization. And all of these also have a manifestation in the Leicestershire landscape. Hunting and gathering has very deep roots. It goes back 3 million years. For 3 million years, we as a group of species have been making tools that we could use to manipulate the environment around us. And by the time we start to record signs of modern behavior in archaeological settings from about 40,000 years ago, in cave art, for example, from Europe, and in cave art from Indonesia, we also start to show signs of our very significant impact on the landscape around us. And certainly from about 40 to 50,000 years ago, as anatomically and behaviorally modern humans start to move around the world, we start to have a clear and significant impact on the animals and more broadly on the flora in the landscapes around us. Many of these large animals, the megafauna, the big animals like the mammoths that were more than 44 kilograms in weight, start to disappear from the landscape. It's a pattern that we can see globally. It's a pattern that is still unfolding today as we remove the habitats for these organisms. It's a big impact. And you might say to me, why wouldn't we think about defining the Anthropocene much deeper in time? The reason is that actually there was much more to come. We were going to have a much more significant impact through landscape domestication. When we started to do this at multiple sites around the world from about 13,000 years onward, we really did have a dramatic impact on the landscapes of Mesoamerica, of Africa, of the Levant, and of East Asia. And for me as a paleontologist, that's also left a very, very distinctive signal that I can read in the sedimentary record of our planet as we altered these landscapes very, very considerably. We can see that in the Leicestershire landscape, for example, unfolding over thousands of years. And another one of my PhD students, Anna Sellers, who I hope will be able to make contact with some of you, is doing this in the Leicestershire landscape to look at when the most significant changes were, and also to look at what ecosystems and ecologies have been resilient to this change over hundreds and thousands of years. Now, those changes were also very, very significant, but there were even more profound changes to come with globalization. So we've had the impact of hunting and gathering, we've had the impact of landscape domestication, but in fact, globalization has perhaps had the most profound impact on our planet. This picture, I think, is very prescient in that sense because it's showing you the trade, the maritime trade of major commodities. And you could almost see these major arterial flows as the lifeblood of the technosphere, of this emergent system, which is now autonomous from us, which is emerging out of us, but which has its own kind of ability to generate its own trajectory. Let's just think about globalization for a moment and think about its impact on the landscape. So this is the globalization of maize. Maize, of course, as a crop was developed in Mesoamerica and was first cultivated perhaps 9,000 years ago in Mexico, and then spread out across the Americas. And then after the Columbian Exchange, from the early 16th century onwards, started to spread throughout the world. And this too, like hunting and gathering and landscape domestication, has left a very distinctive signature that we can find not just in the landscape, but actually in the fossil record. So I could take you to Lake Baringo in East Africa. We could go out into the middle of the lake. We could core the lake, so we could bring up a sediment core, and then we take that sediment core back to the lab and we would analyze it in detail. And what we'd find is, as we went back through the core, around about 1750 onwards, we find evidence for maize, for corn pollen in an East African lake. And of course, this can only be a product of globalization. It can only be a product of humans translocating maize across the planet. And these kinds of signatures in sediment cores occur everywhere across our planet now. It's also during this interval of globalization that we really start to see a beginnings of what's being called an homogenization of ecosystems and ecologies. This is a famous study from a German scientist just trying to plot up the rate of translocation of a whole range of different species across our planet. And you can see how this has really accelerated over the past 2 centuries. We've been doing this for thousands of years, but we've really accelerated this process over the past 2 centuries, and that includes into the Leicestershire landscape also. And then in the 20th century, as a result of globalization, we have a really explosive development and change. You can see that in the architecture of cities around us, in a city like Leicester also. If we went back to the 9th century into our landscape, our English landscape, and we look at the architecture, it's very distinctly Anglo-Saxon, like the beautiful Anglo-Saxon church at Brixworth there on the top left. Or if we were lucky, we could travel to Vietnam, and we could find some beautiful temples from its 9th century history in the deep past. And we'd have a sense of a very distinctive biogeography of culture. You can clearly see that that temple in Vietnam is very different from that church in the English landscape. But now track over to the right-hand side of this figure. The top is London and the bottom is Ho Chi Minh City, and they're almost, indivisible in terms of the materials they're made from. They're made from steel and concrete and plastic and glass, the materials that are being globally traded by the technosphere, and which have also left a very distinctive geological record in the sedimentary accumulation. So a distinct change, particularly in the later part of the 20th century. And that's also been tracked by one of my colleagues, Will Stephan, who sadly passed away a couple of weeks ago, in these amazing great acceleration graphs, which again show you just how rapid the change is in the 20th century. And of course, the one that always gets the most attention here is the spread of McDonald's restaurants. And it really is quite amazing because there are 39,000 of them on the surface of this planet. And if you add them to the 19,000 Burger Kings, you could stack up those restaurants from New York to Chicago and eat burgers for the entire journey. This is the rate of change that is characteristic of the later part of the 20th century in the Anthropocene. It also dovetails with a signal of our ability to cause huge damage to the broader Earth system with the radionuclides that are dispersed across our entire planet and which we can find in our local landscape and everywhere on this planet as a signature of the detonation of atomic bombs in the middle part of the 20th century. I'll come back to this a little bit later. I want to ask now, how granular is that record of the Anthropocene? So I've tried to emphasize that processes of human change are manifested in the landscape over a very long period of time, but that the changes to the landscape and the changes to the Earth system are really accelerating as we go into the 20th century. We should ask the question, can we recognize this signal everywhere we go? So could we see it in the Leicestershire landscape? Could we see it in San Francisco Bay, for example? I think we can argue that we can. And I think certainly some of my PhD students are really trying to develop models of how this has changed. We can see it, for example, in Jenkins' spire snail, yes, which is an introduced species which arrived into the UK in the 19th century and is certainly present in Leicestershire. But we could also see it if we went to lakes or standing bodies of water in our county. This is Groby Pool. And if we went to Groby Pool and we went out and cored that lake and brought up a sedimentary succession, a few tens of centimeters below the lake bed, we'd find a cesium spike from the 1960s. As that radiogenic material was spread about our planet, it's also here in the Leicestershire landscape. And I just want to emphasize to anybody listening, this is nothing to worry about. These are low levels of background radioactive isotopes, but we can measure them as an indicator of this bomb spike in the mid part of the 20th century. I want to take you somewhere, though, where this has been studied in enormous detail and where I hope in due course we'll be able to arrive at a similar kind of level of study with the Leicestershire landscape also. But I want to show you, first of all, San Francisco Bay. because it's one of those places on planet Earth where these changes have been studied in immense detail. San Francisco Bay also sits at one of the kind of key points on this global maritime trade, these arterial systems of the technosphere, if you like. And it is one of the busiest ports in the Pacific and one of the busiest ports on the western seaboard of the USA. And as a result of that, San Francisco Bay has seen a very, very dramatic change to its ecosystems. You can see the figures here, 230 plus species have introduced over the past 150 years, and half of those introductions occurred in the last 50 years. So again, part of this accelerating process that we can see as part of the Anthropocene. And the really striking figure for me is that in some parts of San Francisco Bay, non-native organisms account for 97% of all the organisms and 99% of the biomass, which means that this is a wholly reconfigured ecology. This is a human reconfigured ecology. Let me show you what this looks like. The manila clam, for example, arrives in the middle of the century in about 1946. Bottom right, you can see there what manila clams look like when they proliferate in the bay. Often as many as 2,000 individuals per meter squared, obliterating ecospace for the native species. So you can go out into San Francisco Bay, and this is some work done by a former PhD student of mine. You can put some cores down. Here we're doing it with the United States Geological Survey. You can bring those cores up, and you can examine the record of these species introductions into this wholly changed ecology of San Francisco Bay. What you find is a whole range of non-native species, some of which have never been documented before because they're tiny and therefore very difficult to observe. Here, what you're looking at are a range of different organisms. The A's and B's there are ostracods. These are tiny crustaceans. If you've got a garden pond, you'll almost certainly have ostracods living in it. The D's there are foraminifera. These are tiny single-celled organisms that make a skeleton. And on the right-hand side there, you've got clams. That clam is actually the Amur River clam. It lives in East Asia, but it's now really enjoying itself in San Francisco Bay. And it really is enjoying itself. You can see that the Amur River clam was introduced into San Francisco Bay in 1986. Within a few years, it became very prolific. And then a few years later, it became prolific to the extent of obliterating everything else around it. Basically by consuming all the available food in the ecosystem. So truly a species that is invasive in all senses of that word. It's not the only one, sadly, because this tiny single-celled organism, Trochamina haydii, that makes this skeleton, also found its way into San Francisco Bay, and its native ranges seas around Japan. But you can see from this figure here that when it found its way into San Francisco Bay, it basically, by competitive replacement, became the dominant species on the seabed of the bay, and has displaced the species which we know has been dominant here for thousands of years. The same pattern emerges everywhere we look. We could travel across the Pacific to Hawaii if we were lucky enough to be able to do that. We could go into the Hawaiian Islands and we could find exactly the same signature. Many of the species in the Hawaiian Islands are non-native, of course, and this introduction of species has taken place over a very, very long period of time, probably over nearly 1,000 years since the first Polynesian people arrived there. But it's accelerated in the 20th century by the deliberate introduction of the giant African snail. I don't quite know why that should be introduced to the Hawaiian Islands. And bottom then, the deliberate introduction of the cannibal snail to try and control the population of giant African snails. But of course, the cannibal snail does exactly what it says on the tin. It eats other snails, and it ate its way through lots of the indigenous snails also, and is implicated in the demise of George the Hawaiian tree snail that we were talking about at the very start of this talk. Again, these are very strong signatures of change to the environment around us in the later part of the 20th century. And for me as a geologist, they've left very distinctive fossil signals. So here you've got a sinkhole succession. And on the left-hand side, you've got the stratigraphy of that sinkhole succession going back. You can see nearly 6,000 years. And you can see that through most of the sinkhole sedimentary succession, it's the native, the indigenous snails that you find as fossils. But then when you get to the 20th century, all of those indigenous snails disappear and they are replaced by these invasive snails, and by the giant African snail and by the cannibal snail, again leaving a very, very distinctive signature of very fundamental change in the 20th century. So I've spent quite a long time trying to emphasize to you just how significant these impacts are. And as my PhD students, I hope working with some of you out there, seek to kind of explore the same kind of patterns in the Leicestershire landscape and the patterns that they've left over thousands of years. I hope that we'll be able to get to an understanding of our landscape rather similar to the kind of understanding we have of the San Francisco Bay ecosystem, and it can perhaps become a model actually for understanding how these ecologies have changed. But I just wanted to take stock of our impact at this point, and I hope you'll forgive me at the very end of this talk for just perhaps delving a little bit into polemic, because we can see, I hope, or at least I hope I've been able to demonstrate to you that the growth of the technosphere, if we believe that, if we think that's a good definition of what's happening, appears to be overwhelming the biosphere. And the impact of the technosphere, again, as I hope I've demonstrated to you, is much greater than simply climate change. Climate change is a huge problem for us, but it's one component of what is actually a much bigger change to the Earth system. Now, for me as a geologist, working over hundreds of millions of years of time, I can demonstrate that the changes to the biosphere on our planet are completely unprecedented. There's nothing like this anywhere in the geological record of our planet before. Our impact is truly unique. It leaves a fossil record that is unique, and I've hopefully been able to demonstrate that to you. It also shows that we are dealing with something which is irreversible. You know, the ecology of San Francisco Bay cannot be returned to a pre-human influence state, but perhaps we can work with those ecologies to make them viable and resilient to future change, so that in some way we're able to preserve the biodiversity on our planet. And also what I hope I've been able to show you is that this is an accelerating pattern of change, and it is a rapidly accelerating pattern of change, which means that we need to be very wary of what we're doing to the Earth system around us. I think there are two likely outcomes for the near future. I think you also would be able to predict this, that human changes to the Earth system continue with their present trajectory. They become short-lived and unsustainable and are marked with a mass extinction. We don't want that to happen, obviously. The other possibility is that we're able to quickly develop a more mutually beneficial relationship between the Earth system and its human technosphere component. So that we can evolve it to a system where it's much more mutually beneficial in its workings, the way the other components of the Earth system work to make this a habitable planet. But I do think that for the latter to happen, we have to challenge some of our notions of how we live sustainably with nature. We cannot simply replace one form of consumption with another form of consumption without potentially pushing down the problems of our interaction with the Earth system down the road. So using electrical vehicles may help in the short term to alleviate some of the pressures on climate change and on atmospheric CO2, but we need to be bolder and much broader in our thinking as we go forward. Because if we understand the technosphere properly, more consumption, even if that's supposedly more sustainable, will not stop its voracious appetite for resources. Instead, of course, we need to design human ecosystems that resemble natural ones much more closely. Cities and indeed rural landscapes that seek to emulate the way that natural ecosystems work, because it's those that have co-evolved with the available materials in the landscape to enable them to be sustainable over very long time frames. And actually some civilizations have been very good at doing this in the past. Tokugawa Japan is not a panacea because it was very hierarchical, and it was very severe in the way in which it dealt out punishment to people who didn't adhere to the rules. But it was nevertheless a very interesting interval in Japanese history from the 17th century to the 19th century when Japan was closed, in which Japanese culture evolved a whole series of mechanisms for dealing with finite resources because it was closed off from the rest of the world. It was very good at developing circular economies. There were whole industries of artisans repairing pottery, repairing metalwork, and also it was very good at preserving its natural habitats. And that's kind of carried on in the way in which Japanese people interact with their natural habitats in their landscape. If we can slow the pace of consumption, that actually might buy us some time to help guide the technosphere towards a more successful and mutually beneficial relationship with the biosphere. And I wanted to finish off, I'm sure you probably already know about this, but I just wanted to, if you didn't know, refer you to some of the work that's been done by Kate Raworth and her team, looking at models of donut economics, really thinking about human ecologies that are much more embedded in natural ecologies, that are not working simply along a model of continuous growth, that are predicated on the idea of infinite resources, because we know that that simply is not possible, not in a system where the resources on our planet are finite. We have to find a much better way of existing with the Earth system around us if we want to have fully sustainable livelihoods and a fully sustainable future. Because we live in the Anthropocene, and the Anthropocene is telling us that if we carry on consuming in this way, we're going to cause a calamitous problem with the broader Earth system. And I wanted to finish finally again by, if you hope you don't mind that self-advertising here, but my PhD students are putting on this fantastic set of displays and talks called The Time Travelling Environmentalist Guide to Leicester. You can see it's there at Leicester University on March the 23rd. It's free to all. You can see the registration. I think we're even going to feed you. There'll be wine and food and stuff. And also just to flag some of the absolutely brilliant work that they're doing, because they're really trying to understand how our landscape has evolved over a very long time frame, and to actually think about what patterns of resilience have occurred in the past, which might be useful in terms of thinking about the resilient landscapes of the future. So if you're interested in any of these areas, invasive species there, you can see Amy. If you're interested about our relationships with water in the county, there's Molly. Hannah is doing some absolutely brilliant work in trying to understand how our landscape has gone through major transitions, all the way back from the impact of hunter-gatherers through landscape domestication to globalization. And there is Rachel, who I think was the key organizer of this event, the Time Travelling Environmentalists, who's studying changes in the composition of terrestrial ecosystems as a result of introduced species. So thank you very much for listening to me, and I hope all the slides did work in the end. I'll finish there.
Thank you, Mark. Thank you very much indeed. Thank you for an excellent, thought-provoking and interesting presentation. I think for me anyway, you've raised loads of questions in my mind. But before we finish, can I ask if anyone else has got any questions for Mark or any quick thoughts on what we've heard? Please don't be shy. Yeah, Klaus, please, thank you. Put your hand up.
Hi, that was really interesting. Thank you so much. I'm curious about the pace of change that you would deem necessary, Mark, to avoid the catastrophe that you otherwise see unfolding.
It's a great question, Klaus. I mean, the models for how we can interact much more sustainably with the Earth system are there. There are some really good models out there. I mean, I think if you don't know Kate Raworth's work, it's well worth looking at. I'm sure you do, because it's very well known now.
Yeah, it's good.
And it's just that we obviously need we do need to make the transition fairly rapidly towards ecologies that are much more grounded in the way that natural ecologies work. I mean, I showed you those back of the envelope calculations for the way that Leicester as a city consumes energy, you know, compared to how the natural biome consumes energy, and ultimately, you know, until we're able to use something like nuclear fusion technology, we are limited by the resources that we have at the surface of this planet, and we've got to transition to a system where we are. It's an incredibly difficult question to answer. Sorry, I'm floundering a bit because you know the pace of human change is so rapid, and our ability to modify our governmental systems is not keeping pace with that, and we need to speed it up. But we've got James here and others, Lucy and Kaylee. You know, these are the folks who are at the cutting edge of doing this and dealing with all of these problems. I mean, I'm somebody who quantifies the problems. I'm always well aware of the fact that I'm not somebody who's been very good at finding the solutions.
Thanks very much.
But I'm also hoping my PhD students are going to be quite useful in this context too. So Klaus, please come to that meeting at Leicester. Yeah,
magic, sir. Thanks so much.
Thanks for that question, Klaus. Lucy, you've got your hand up as well.
Yeah, it was just a response really to what Mark said about how quickly we make change. I think education's a really interesting one, and someone's asked the question, are many politicians aware of the technosphere? Well, I think if you don't work in an area where these terminologies are used, you won't be aware of it. And I think that's the point of things like Parish's Nature Network, some of the work that we're doing through the Carbon Net Zero campaign, is to make people aware of what's actually happening, and then it's looking at the solutions. Because I think until you understand a concept, you know, what it means to lose a snail in an ecosystem, you don't really understand that it's important to take it seriously. So I think this is a good start, and thank you very much, Mark, for your presentation. It's excellent, and it's good to hear these things in context at a global level, because whilst you can see certain things in the Leicestershire landscape, putting it at that context really makes us understand the serious nature of our impact. So thank you for that.
Thank you, Lucy. I should say as well, if anybody wants my slides, you're welcome to them. Really, the more people we can influence, the better. So.
That'd be great. We can share it actually, Mark, on the Leicestershire Communities probably website after this for members, certainly for those that are signed up. And we do that with a lot of our presentation. I shall certainly send it to all the people I invited tonight, some of whom have attended, who are environment action volunteers and are trying to get the messages out into their community. So absolutely, we will do our best to get it out as wide as we can.
I'll send you a top copy, Lucy, because I updated it from the version I sent you before. But please, if it's okay, if you don't mind, James and Lucy and Kaylee, if I can, the more people that come to that meeting in Leicester University will be really good too, because some of my students are doing amazing work, and I think, you know, they can. I didn't want to talk about their work because it's for them to talk about their work, but it's, you know, that would be really good.
Excellent, thank you. We'll do what we can to share as wide as the other things as well. Thanks.
Yeah, thanks, Mark. Yeah, no, there's definitely from what you've shown of the event, much of that work kind of linked to the work that we're doing within the County Council and other public bodies are doing as well as members of the public. So I think there's a great opportunity to cooperate and collaborate, etc. Just a question from me, if you don't mind. I was intrigued by you describing the technosphere as autonomous. Is it like we've created our own Frankenstein and it's kind of gone on rampage and is kind of killing its own maker in a way?
So it's very much the idea of Peter Haff. And Peter's coming from an engineering background, so he's coming very much from a systems background. But I can see very strong merits in what Peter's suggesting, because there's the system, the technosphere. We don't have any control over it, James. I mean, you know, you and I have no individual control over the technosphere. I don't think the UK government does. I don't even think, you know, multinational organisations like the United Nations have a control over it. It has its own emergent properties. It's got its own trajectory, and we can influence it. But in order to change the way the technosphere is consuming, we collectively as a species have to start thinking about the way in which we consume. And if we can change our patterns of consumption, then I think we can actually influence the technosphere to be much more sustainable and much more mutualistic in its behavior. But at the moment, I think it's operating, as you say, it's almost parasitic on the rest of the system. And that's a serious problem we've got. But we're not powerless. We can act, but we have to act collectively, I think, to influence it.
I suppose the difficulty is that you say act collectively, but we are, I suppose, fighting against billions of dollars being spent on telling us to consume and that we won't be happy unless we consume, etc. So it's not a downhill battle. It's a really very much an uphill battle, isn't it, against the system? It
is, but as long as we keep trying, we're doing our best.
Yes. Yes. Thank you. One other question, just conscious of time for me, is you at the start you talked about our population and compared it to other populations of other mammals, etc. And I wondered, from a geological time point of view, is it unnatural for a species like humans to be so many?
Yes, it's very much a function of our interaction with the technosphere, which has allowed us to burgeon into this 8 billion. But you know, that's a remarkable figure. We as a single species are more than 99.9% of the numerical abundance of all primate diversity, and I cannot think, looking back through the geological record, of that ever happening before, for one species to be so dominant in that way.
Yeah. If I can just recommend a book, if anyone has the opportunity to read the book *Sapiens* by Yuval Harari, I think it's an excellent book for giving you that kind of global perspective and geological time perspective of the impact of humans as well. So it's a good. For me, it was a kind of a life-changing book to give me that kind of bigger picture understanding. Okay, any other questions, folks, from anyone? Just check on the chat. Okay, doesn't seem to be. Okay, it's 7:30, and we said we'd finish at 7:30. So can I thank you all very much for joining us? Can I thank Mark for an excellent presentation, as I said? And I see Lucy's posted in the chat. We've got a couple of other seminars taking place. I think it's, what was it, Thursday and Friday, is it? Or Thursday and Saturday, Lucy?
Yeah, Kaylee's put the dates in the chat. We've got one on Thursday about biodiversity in the home. Then around lunchtime Friday, it's all about climate adaptation and nature. And then on Saturday, we've got one about community woodlands, how to create them, how to manage them. And that's been done by Rural Communities Council, sponsored by National Forest and the Lottery. So they'll be really interesting, and I'll certainly be joining. Thanks.
Thanks, Lucy. Thanks for that. Okay, well, have a good evening, folks. Thanks for joining us, and hopefully we can see some of you in the future as we try and tackle the problem across the county and city and wider field. Thank you all for your contributions and time.